Welcome to Day 3 notes and the often confusing topic of thermochemistry and thermochemical equations. So today we're really going to look at how we use these thermochemical equations and look at what a delta H of a reaction is. Delta H is basically the change in the energy when you're looking at the reactants versus the products. A thermochemical equation is a chemical equation which includes the energy used or produced in a chemical reaction. Every reaction has an energy change associated with it. Energy can be traced from the reactant side to the product side. We call this enthalpy, and it's going to be symbolized by a capital H. It's the heat content of a substance at a constant pressure, so we can measure the change of a substance. The heat of the reaction is that change that happens during a chemical reaction when energy is absorbed or released. The delta H, remember delta always means a change, in this case change in heat, will be the change in enthalpy per mole of a substance. So we're going to be looking at those mole ratios to determine how much energy is produced. So there are two basic types of reactions, an exothermic reaction and an endothermic reaction. We're going to look at the exothermic reactions first. Now, whenever you see a negative sign, this means that the reaction is exothermic. You'll see in some of the example problems, we have to really pay attention whether the question is telling us that the chemical reaction is exothermic or endothermic itself, and make sure that our signs will match up with that. We'll see an example in just a minute. So whenever you see a negative sign, it's an exothermic reaction. If you see a positive sign, it will be an endothermic reaction. In an exothermic reaction, energy is a product. So we could think about this as being these products plus energy that's being released. An endothermic reaction can be shown in two ways also. Where we're looking at the final product is that a positive sign will mean that we have to add energy to the reactants in order for the reaction to happen. So a positive sign means the reaction is endothermic. Energy is a reactant in an endothermic reaction. This reaction won't happen unless I add energy to it. The heat of a reaction, or the change in the energy, is the amount of energy used or produced when the coefficients equal the number of moles in a reaction. And we'll take a look at this a little closer. The coefficients of any substance will equal that delta H. So if we have a coefficient of 2 in front of, let's say, water, that will equal the total delta H. This can be used as a new conversion factor. We'll be looking at, say, 2 moles will produce this much energy or will need that much energy. To summarize this, where the positive and negatives come from is looking at the energy that's present in the reactants at the start of the reaction. If the number is positive, that means you have to add or plus that amount into the reaction for it to happen. This will mean that it's endothermic. Energy must go in. If the number is negative, you'll have that much less energy in your products, and that extra energy is going to be released into the surroundings, meaning that it's exothermic. So if you're looking at a question like how much energy is needed when 1.27 moles of sulfur reacts with excess carbon. So we know we've got more than enough carbon for this reaction. This is our limiting factor. Well, if you're looking here, we need 1 mole of carbon per 2 moles of sulfur to produce 1 mole of carbon sulfide, or carbon disulfide. We have less than 2 moles here, so we're going to predict that the amount of energy that's needed is going to be less than this amount because we don't have 2 full moles. So let's take a look at the calculations. As always, we're going to start with what we know. We know we have 1.27 moles of sulfur. My unknown is how much energy is needed. So the units for energy is going to be kilojoules. I'm going to be looking at the mole ratio, or the mole coefficient, this 2. And I'm going to be using the delta H, the change in heat. Again, it's positive. So I know heat has to be added into this side in order for this reaction to happen. My mole units have to cancel out, so 2 moles of sulfur will produce 89.3 kilojoules of energy, or will be needed. Make sure my units cancel out. And I'll need to have 56.7 kilojoules. So 56.7 kilojoules will need to be added into this in order for the reaction to happen. This is an endothermic reaction. My delta H is positive, so I need to add in energy for this reaction to happen. The energy is needed, so that's your clue that this is an endothermic reaction. And then in this case, it also confirms that with a positive delta H. How many moles of water would be produced if the reaction gave off 347.1 kilojoules of energy? So here's our balanced chemical reaction. And you can see the part given off, there's no delta H here. So we can see that if we have 2 moles of oxygen, 1 mole of methane, it's going to produce this much energy. It's going to give off that much energy. So we start with what I know. Now, because this is telling me it gave off 347, I know this is an exothermic reaction. Again, there's no delta H here, so I have to make sure that I convert this for myself. That's going to be negative because it was given off. I'm asked to calculate how many moles of water. Here's my mole ratio, or my ratio of number of moles per amount of energy. Make sure my units cancel off. Again, this is the amount that's given off, so I need to be sure that it's a negative number when I put it in my formula. 2 moles of water will give off this amount of energy. Cross off my units, and there's my total, 0.7796 moles of water. Again, less was given off than the full reaction, so I know I don't have full moles. How much energy is produced when 75.0 grams of oxygen reacts with excess ethanol? There's our balanced chemical reaction, and again I have a positive 1,235 kilojoules. How much energy is produced tells me it's exothermic. So there's my grams. I know I've got this many grams. I now have to convert that into moles, because I need to know how many moles of oxygen I have. So 32 grams of oxygen per mole. I'm going to be using 3 moles of oxygen, which will produce 1,235 kilojoules. This is an exothermic reaction, so I need to make sure that my sign is negative. Make sure my units cancel out. And it's going to produce 965 kilojoules. So now it's time to practice some of these questions on your own, and I'll be right there to help you along. These are kind of confusing, and once you get the hang of where the energy is being produced or added, these are not too bad. Let's give it a try.